Let us understand the basics of optical, thermal and microwave remote sensing and the concept of LiDAR today. In this lecture, we will understand the basic of optical, thermal and microwave remote sensing and the concept of LiDAR. I have provided you with the ebook on principles of remote sensing. There are various authors who have compiled this book. So if you go to page number 63 of this book, here, okay, you will find absorption and transmission. Now we already know that how the electromagnetic energy it interacts with the earth's surface, right? The EME comes from the sun, some of it is absorbed, some of it is scattered and some of it is transmitted back. So the energy which is transmitted back is sensed by the sensor and this is finally used for interpretation. Now the amount of energy which comes to the Earth's surface and after interaction with the surface it comes to the sensor, after which we interpret it. So we have certain certain points where we have to understand that the sensor is capable of sensing only some part of the electromagnetic energy. We have already discussed this. So there are particular gaps or windows, okay, through which some part can be sensed. Like you have a window in the room. If you see a window in a wall, you will be able to see something outside of the window, not through the wall. Likewise, this word window is also used. If we see the electromagnetic spectrum, here it is not very clear, but it is just to give you an example. You already have a very high definition figure of this, and I hope you must have also drawn it till now. So we know that there is a particular range which is visible from 0.4 to 0.7, right? So within this, the blue, green, red, these are the wavelengths which are easily identified by the human eye, so they are visible. So this window from 0.4 to 0.7, okay, imagine if this is a complete wall of the spectrum, so you have these windows, right? So this window is the window of visual spectrum. Likewise, we have this thermal and then the microwave one. So thermal usually is taken from 8 to 14 micrometer, and microwave is taken from 0.1 centimeter, that is 10 mm, and after that, okay. So I suggest you to draw this electromagnetic spectrum showing various windows: the visible window, its range, the thermal window, its range, and the microwave window with its range, okay. The same is shown here also, and these spectra which are shown, these are giving you the absorbed part of the molecules, the H2O, CO2, okay. So atmospheric windows, if we see their definition, these regions outside the main absorption band of the atmospheric gases, they can be used for remote sensing. So when we are talking about the wall has certain bricks, okay. Those bricks or the cement or the material which has made the wall, it doesn't allows the electromagnetic energy to pass through the wall, right? Likewise, what happens is, in the atmosphere there are various gases which absorb some of the electromagnetic energy and do not allow it to reach to the surface, and sometimes even if they reach to the surface, they are not easily taken in the images, okay. So those areas, the wavelength regions which are outside the main absorption band of the atmospheric gases, they are known as atmospheric transmission windows, okay. So if somebody asks you that what do you understand by atmospheric transmission window, so a simple definition is the wavelength region outside the main absorption band of the atmospheric gases. In the bracket you should write ozone, water vapor, air, carbon dioxide, bracket closed, can be said to be atmospheric transmission windows, okay. So they are mainly of three types. That is why we are understanding optical, thermal, and microwave remote sensing only, Okay, they are mainly of three type. Within this also we have various with time, with the increase of better technology, we are being able to get very narrow bands also, but mainly we will talk as of now about optical, thermal and microwave remote sensing only. So a window in the visible and reflected infrared region, that is from 0.4 to 2 micrometer. Okay, from 0.4 here to 2 micrometer, somewhere here, reflected infrared. Okay, it will be somewhere here. This is a logarithmic scale. In fact, it is not to scale also, but this is how we show a log scale. That means the differences here are not equal, they are in the logarithmic sequence. Okay, so this visible and reflected infrared part, this is one of the window which is known as the optical window. Okay, a window in the visible and reflected infrared region between 0.4 to 2 micrometer, this window is known as the optical transmission window. Okay, and those sensors which operate in this window are known as optical remote sensors. Hence the remote sensing which is done here will be called optical remote sensing. Simple. Okay, after this comes the thermal infrared region. There are three windows within the thermal infrared region. We differentiate the thermal infrared region. This is the thermal infrared region after 2 micrometer. From 2 micrometer to somewhere 14 micrometer, it goes somewhere here. Okay, so we have three divisions here. What are these? Two narrow windows around 3 and 5, and a third relatively broad window extending from 8 to 14 micrometer, as I earlier said about the 8 to 14 micrometer. So we have three windows in the thermal infrared region. The first one is at 3, second one is at 5, and the third one is from 8 to 14. So the first one is at somewhere here 3, and then at 5, these are the windows, right? And then the third one is at around 8 to 14. So this region which is shown here in the lighter color shows the part which can be considered as a window, whereas these darker ones, these are the areas which are absorbed by these molecules. This energy is mostly absorbed by H2O. This energy is mostly absorbed by O3. Okay, so these are the windows. So in remote sensing, as of now, we are taking 3, 5 and 8 to 14 micrometer only. Okay, for thermal remote sensing, and in future we will use various other windows also, as you see here. Okay, so the third window then, okay, as of now we have studied the visible one, or say the optical remote sensing window, the thermal infrared remote sensing window. Now let us see the another one, the microwave one. Now more or less transparent region lies beyond 1 mm, as we earlier saw, beyond 1 mm or 0.1 centimeter. This is a very wide range. After this you have a long range where you can find the window. Okay, so we are now talking about this, that is from 0.1 centimeter and beyond that, or you can also say from 1 mm and beyond that. Okay, so this region is known as the microwave region. Now let us see this diagram. This diagram shows the electromagnetic spectrum of the sun as observed with and without the influence of the Earth's atmosphere. So if we are talking about the interference of the molecules of water, carbon dioxide, of ozone, which are present in the atmosphere. So if we see that there was no, say if there was no atmosphere, that is there was vacuum, how would be the spectral curve? And if there was the atmosphere, then how would be that spectral curve? So it more or less it is not changing, right? But it has some bumps here. Okay, due to these we find the windows. So we talked about three windows as of now. The optical one, which goes from point 4 to point, sorry, point 4 to 2 micrometer. Okay, point 4 to somewhere here, sorry, let me show you this diagram. Point 4 to 2 micrometer here. Okay, one window. This is the optical window, which includes the visible and the reflected infrared part. Point 2 to, sorry, point 4 to 2 micrometer. Okay, then the other one is thermal infrared window. Within this we have two small windows at 3 micrometer and 5 micrometer, and then the third one is at 8 to 14 micrometer here. Okay, so the first one is the optical window with visible and reflected infrared. From point 4 to point 7 is the visible one, and then it goes up to 2 with the reflected infrared. Okay, so point 4 to point 2 is the optical, sorry, point 4 to 2 is the, point 4 to 2 micrometer is the optical window. And then the thermal window, there are two small narrow windows at 3 micrometer and 5 micrometer, and a range of wavelength lying between 8 to 14 micrometer. This is the thermal infrared optical window, sorry, thermal infrared window. And then the third one, the microwave one, it starts from 0.1 centimeter or say 1 mm and beyond that. Okay, so these are three atmospheric transmission windows. Let us revise once more. The first one is the optical window, which has the visible and the reflected infrared. It starts from 0.4 to and goes to 2 micrometer, 0.4 to 2 micrometer. Then is the thermal infrared. It has three windows in it. The narrower one are at 3 micrometer and 5 micrometer, and the one with the larger wavelength lies between 8 to 14 micrometer. The third one is the microwave window, which lies from 1 mm or 0.1 centimeter, okay, and beyond that. So these are various atmospheric transmission windows, right? So these optical, thermal and microwave remote sensing techniques are used in these windows only. So when you are talking about optical remote sensing, you are using those sensors. You are using those sensors which are active or which can sense this wavelength, 0.4 to 2 micrometer. And then when you are talking about thermal remote sensing, yeah, you are talking about thermal remote sensing, then you are talking about these three windows at 3, 5 and the range between 8 to 14 micrometer. Okay, then when you are talking about microwave window, you are talking about the area which is beyond 1 mm. Okay, so these are the windows which are used for optical, thermal and microwave remote sensing. Now we have understood about various sensors. We have even talked about whisk broom, push broom sensors, and various examples are also already given to you. Like I told you about the LIS sensor. I'll talk in it. I'll talk about detail in detail also. So what we understand till now is that various sensors are used in remote sensing. Those sensors which can sense the wavelength between 0.4 to 2 micrometer, they can be used in optical remote sensing. Those which can sense between at a narrow range of 3, 5 and then between 8 to 14 micrometer range, they can be of thermal. And then